Hi students, today I am going to explain the chapter first in 10th class chemical reactions and equations. You already learnt about physical and chemical changes of matters in your lower classes. Whenever a chemical change occur, we can say that a chemical reaction has taken place. Then what do you mean by chemical change? It brings change in the chemical properties of matter and we get new substances. Chemical reactions means the substances that undergo some chemical changes. Examples for chemical changes are digestions of food, cooking of food, rusting of iron, etc. Next, what do you mean by physical change? It brings change in the physical properties of matters like color, melting point, boiling point, etc. A physical change is a interconversion of state. Understand? Examples for physical changes are mm, melting of ice, mixing of sands with iron fillings, like that. Observe this figure. In figure A, it one beaker and it contains a quicklime. Figure B, we add water for this quicklime. It becomes calcium hydroxide. Okay, calcium hydroxide, sorry, calcium oxide, that is quicklime, and its formula is CaO. Quicklime reacts with water to form a slaked lime, releasing a lot of heat. Means quicklime undergoes some chemical changes. Means quicklime reacts with water. CaO plus H2O gives rise to calcium hydroxide, that is CaOH twice. The beaker becomes hot and its temperature is increases. So this is the best example to show that quicklime undergoes chemical changes. So it forms a new substances, that is calcium hydroxide. What do you mean by chemical reactions? Substances which undergo some chemical changes is called chemical reactions. Whenever a chemical reaction takes place, following changes will occur. First change is change in state. In this figure, one container contains liquid and another one is means right hand side. The liquid becomes vapors. On heating, liquid changes its states and converts to vapor due to reaction within the particles caused by heat. This is change in state. First, it is in liquid state and applying heat to this liquid, it becomes vapor. Means change in state. Liquids changes into a vapors. So next change is change in color. Observe the silver gets tarnished when kept for a long time. The metallic silvers reacts with hydrogen sulfide or sulfur that are present in air and gets tarnished. Observe this reaction. First, silver means Ag reacts with hydrogen sulfide that are present in atmosphere and oxygen that are also present in atmosphere. It gives rise to silver sulfide means Ag2S. This compound is uh, makes the silver tarnish and along with water molecules. Understand? Next change is evolution of gases. During aerobic cellular respiration in human body, energy molecules combines with inhaled oxygen and release energy needed by the cells. It also releases carbon dioxide and water. Here is the overall reactions for aerobic cellular respiration. So first glucose means C6H12O6. It reacts with inhaled oxygen, gives rise to carbon dioxide gas, water molecules and energy. Energy that are stored in our cells in the form of ATP. Next change is change in temperature. Means quicklime reacts with water to form a slaked limes and releasing a lot of heat. So the becomes hot and its temperature is rises. Understand? These four changes helps us to determine whether a chemical reaction has taken place. Next topic is chemical equation. Means description form of a chemical reaction is called chemical equations. Describing all of the chemical reactions that occur around us in words is quite impossible. Like, if you want to depict the formation of magnesium oxide, instead of writing the phenomenon in sentences, you can simply write it as magnesium reacts with oxygen, it gives magnesium oxides. We write the whole phenomenon in the form of equations. Understand? Magnesium reacts with oxygen, it forms a magnesium oxide. This is known as a word equation and itself describes the whole phenomenon of formation of magnesium oxide. Through this, we can conclude that magnesium on reacting with oxygen present in atmosphere and gets converted into magnesium oxide. Okay, magnesium itself, it forms magnesium oxides when it exposes to atmosphere. Okay, so before burning the magnesium ribbon is nothing but a pure magnesium metal. Before burning this magnesium metal, first we should clean that. Why? Because magnesium when exposed to atmosphere, it reacts with oxygen that are present in atmosphere and it makes a magnesium oxide layer on the surface of the magnesium ribbon. So we must clean the magnesium ribbon before burning. Understand? Why should a magnesium ribbon be cleaned before it is burned? Because magnesium is a very reactive metal and it reacts with oxygen and it forms a magnesium oxide on its surface. This layer of magnesium oxide is quite stable and prevents further reactions of magnesium with oxygen. The magnesium ribbon be cleaned by a sandpaper for removing this layer on that the underlying metal can be exposed to air. Understand? Points to be kept in mind while writing chemical reactions. Observe this equation. Here it's a general equation. Understand? Here A and B are the reactants that are present on left hand sides. AB is the product that are present on the right hand side. What are the points to be kept in mind while writing chemical reactions? So first point is the reactants are always written on the left hand side with plus signs in between the reactants. In general form of equation, reactants are A and B. So we put plus sign in between these two reactants, A plus B. Okay. Next, the second point is the product is written on right hand side. Always the product or lies on the right hand side. Next point is in between reactants and product lies the arrow sign. Okay, see third point, there is a arrow sign. Next, fourth point is the arrow head points towards the direction of reactions. Okay, A plus B combines means it reacts to give a new product. Understand? You can also add the conditions and catalyst required to perform the reactions above and below the arrow signs. Okay, conditions, it become a temperature, pressures, uh, physical states. Catalyst means it helps to increase the rate of the reactions. Examples for catalyst are hydrogen, nickel, palladium, etc. Okay, you know about the chemical equations. Chemical equations means the description form of a chemical reactions. Okay, this chemical equations always should be balanced because to maintain the law of conservation of mass. So what it states, law of conservation of mass means it states that mass can neither be created nor be destroyed, but it is converted into one form to another. Understand? So balancing a chemical equations balances the amount of reactants and product on both the sides of arrow, means on a reactant side also and in product side also. An unbalanced chemical equations, for instance, chemical equation for rusting of iron is given by, okay, the chemical equations for rusting of iron is Fe means iron plus H2O water gives rise to Fe3O4 means ferric oxide plus H2. Okay, Here this equation is unbalanced equation. So what we call this unbalanced equation? Skeletal equations. Understand? The unbalanced equations, we called it as a skeletal chemical equations. So see here in reactant sides, iron atom is only one. In product sides, there are three iron atoms are present. And next, hydrogen here two, and product side also two. In the reactant side, oxygen is only one. In the product side, oxygen is four atoms. So for this reason, and to maintain the law of conservation of mass, so we should balance this chemical equations. We follow some steps to balancing the chemical equations. So step 1 is, first we draw boxes around each formula. Do not change anything inside this boxes while balancing the equation. We just draw the boxes around each formula, means Fe. So we put one box H2O. It is a one of the it is one compound, and we put one box for water. Next Fe3O4. This is one compound. So we put one box and H2. Next, step 2. List the number of atoms of different elements present in the unbalanced equations. Okay, difference in the above equations means Fe plus H2O gives rise to Fe3O4 plus H2. In that equations, there are three elements are present. One is iron, hydrogen and oxygen. So number of atoms in reactant side. Iron, it presents how much? Only one atoms are present. In the product sides, there are three iron atoms are present, means Fe3. In next element is hydrogen. That are present in reactant side is only two, means H2O. Okay? Two hydrogen atoms. In product sides, there are two hydrogen atoms are present. Oxygen in reactant sides only one, means H2O. In the product sides, four oxygen atoms are present, means Fe3O4. Understand? Next, step 3. The compounds that contains the maximum number of atoms. It may be a reactant or a product. In that compound, select the elements which has the maximum number of atoms. Understand? So first we choose the compounds that contains a maximum number of atoms. So in that equations, the maximum number of atoms that are present in Fe3O4. Okay. So in the using these criteria, we select Fe3O4 and the elements oxygen in it. So Fe3O4, these two elements, so more number of atoms are present. Which atoms are more numbers? That is oxygen. Okay, Fe3 means 3 iron atoms, 4 oxygen atoms. Understand? There are 4 oxygen atoms on the right hand side and only one on the left hand side. Observe this table. Atoms of oxygen initially in reactant sides only one, in product side there are 4. So to balance in reactant sides, in reactant side initially there are only one oxygen atom. So for this reason we should multiply it 1 with 4, means it becomes 4 oxygen atoms on reactant sides, and in product side also 4 oxygen atoms. So we balancing this, we balanced this oxygen atom. Understand? In reactant side also 4 oxygen, in product side also 4 oxygen atom. In step 4, we balanced only oxygen atoms. Remaining 2 atoms are present. One is iron and another one is hydrogen atoms. Pick any of these elements. Either you take iron or hydrogen. Let us balance hydrogen atoms in the partly balanced equation. First I take a hydrogen atoms, and next and lastly we balance it the iron atoms. To equalize the number of hydrogen atoms, make the number of molecules of hydrogen as 4 on the right hand side. Okay, atoms, observe this table. Atoms of hydrogen initially in reactant sides there are 8. In product sides only 2. We make in product side also 8. Okay, so for this reasons we multiply 2 with 4, so it becomes 2 fours are 8. So in reactant side also 8 hydrogen atoms, in product side also 8 hydrogen atoms. Understand? And so observe this equation, Fe plus 4H2O. Okay, 4 twos are 8. Here also in product side also 4 twos are 8. 8 hydrogen atoms in reactant sides and 8 hydrogen atoms in product side. Understand? Next step 5. At last element is this iron elements. Observe these tables, same thing, how we balancing the oxygen and hydrogens, like that same we should balance this iron atom also. The atoms of iron initially in reactant side only one, in product sides 3, means Fe3. So to balance this react in reactant sides, 1 is multiplied with 3, means in reactant side also 3 iron atoms, and in product side also 3 iron atom. So we balance these 3 elements. One is, first we balanced oxygen, and next hydrogen, and next one is iron atom. So we balance these 3 elements. Okay. So see this equation, 3Fe plus 4H2O gives rise to Fe3O4 plus 4H2O. Here 3Fe. Okay. In the Fe3O4, here 3 is present on suffix. Means it's also means 3 iron atoms. Okay. Next comes to hydrogen. There are 4 to 8, means 8 hydrogen atoms in reactant sites. In product, 8 hydrogen atoms are present. Next see oxygen. Here 4 oxygen atoms in reactant sites, and in product side also O4, means the 4 that are exist in suffix. It means also 4 oxygen atoms. In step 6, to check the correctness of the balanced equation, we count atoms of each element on both the sides of the equation. Yes, we count the balanced, we count the number of atoms on both the sides, means reactant sides and product side also. This equation is now balanced. Okay, you just count these elements. So it is balanced. This method of balancing chemical equation is called the hit and trial method, as we make trials to balance the equation by using the smallest whole number coefficient. Okay. In step 6, this equation tells us anything about the physical state of each reactants and products. Yes, it states some physical states. To make a chemical equation more informative, the physical states of the reactants and products are mentioned along with their chemical formula. Is it? The gaseous, liquid, aqueous, and solid states, means these are the physical state that are mentioned in chemical formula. So for example, in gaseous, we write small g. Okay, that compounds that are exist in liquid form means we wrote small l. Next, that compounds are in aqueous state means we wrote a small q, and that compounds are exist in solid states we wrote small s. Understand? The word aqueous means AQ is written if the reactants or product is present in a solution in water. Observe this equation Fe. We wrote small s within the bracket. We wrote small s. This physical states are always right within the bracket, means small s. Means iron that are exist in solid state. H2O. So means gaseous means that water is exist in the form of a steam. Okay, gives rise to Fe3O4, means that are exist in solid form. Next H2 means that are gaseous form. Means iron metal reacts with water vapors, means water vapors that are present in air reacts with water vapors, it forms Fe3O4, means rust, and gives hydrogen gas. Understand? So I concluded my topic. A complete chemical equations represents the reactants, products, and their physical states symbolically. Understand? A chemical equation is balanced. Why? Because why should we balance this chemical equation? Because to maintain the law of conservation of mass, uh, and so that the numbers of atoms of each type involved in a chemical reactions are the same on the reactant and product sides of the equation. Equations must always be balanced, that you know. Next, I will give you the homework. So, first question is, why should a magnesium ribbon be cleaned before burning in air? Okay, second question is, write the balanced equation for the following chemical reactions. First one is hydrogen plus chlorine gives rise to hydrogen chloride. Second question is barium chloride plus aluminum sulfate gives rise to barium sulfate and aluminum chloride. Next question is sodium reacts with water. It forms sodium hydroxide and hydrogen gas. Okay. Don't write the physical status. It's need not to be necessary. You just write the chemical formula. Okay. Thank you all.